some linear equations, and it's going to take several of these videos to put it all together in a place that makes sense. So just take your time as you're watching these videos, but in this unit specifically, you may want to come back to the earlier videos to help things sink in and click better. So we're going to work on interpreting graphs, writing a solution as an ordered pair, which is going to be very important, deciding whether the ordered pair is actually a solution, completing ordered pairs, making a table of values, and plotting those points. So a line graph is a graph that has a line. As mathematicians, we're not very original, so a lot of the times when we name things, we make them easy to understand. So with a line graph, we only need 2 points on the line to play connect the dots. So in this line graph, I would need more than 2 points because it's a data line graph. And so when I'm looking for a data line graph, it's not the same as what we call a linear equation. So a line graph would actually be connecting various points of data, whereas if I was looking for a linear graph, I would just connect 2 of these dots to form an entire line. However, I can estimate points utilizing the coordinate plane, just like if I was in a linear graph. So if I want to look at 2008, the gasoline prices would be between $3.20 and $3.40, so maybe closer to, I don't know, $3.28 or $3.25. If I wanted to look at the average price of gasoline decreasing, I'm going to look at the difference between 2008 and 2009, which when I go roughly on my graph, I can look over and see roughly what it is. And we're just estimating here, and roughly it's 90 cents. So line graphs are going to be very useful when we're looking at data values. What linear equations is going to reference is what I talked about earlier, where we can play connect the dots with any 2 points. A linear equation has 2 variables, and a lot of times that gets forgotten. There's an x and there's a y, because when we graph, we have an x coordinate and a y coordinate. When I write it as ax plus by equals c, that's considered the standard form for the graph of a line. And I've got some examples at the bottom of the screen. So before the first student raises their hand and says, why do we have different equations? It's because they all serve a different purpose. And as you go through these videos, I'm going to take some time to explain the reason why we have these different forms of equations. So we're going to recall from earlier that a solution of an equation where we're solving those equations to get down for x, it's something that makes a statement true. So if I look at this equation, x minus 2 equals 5, if I solve this for x using those methods we learned earlier, I would get that x equals 7. If I wanted to check my work, I would replace the x with 7. 7 minus 2 is equal to 5, so that is the correct answer. The solution of a linear equation has 2 answers, and I'm plugging in 2 values because I have 2 variables now and not just 1 like in the previous example. So when I have the graph y equals 4x plus 5, if I want to check to see if 2 and 13 are a solution, I'm going to replace x and y with 2 and 3 respectively. So that I get 4 times 2 is 8, 8 plus 5 would be 13. That's a true statement. So we know the point 2, 13 is a solution for this. So I can write my solution as an ordered pair that can be plotted on the graph, and I know that that point lies on the line described by that equation. In an ordered pair, the x value always comes first, the y value always comes second. So if I want to decide if it's a solution, then I'm just going to substitute. That's all I'm doing is I'm substituting. So if I look at 5x plus 2y equals 20, I'm going to substitute 2 and negative 5. And I'm going to see if it's true. Is 5 times 2 plus 2 times negative 5 really going to be 20? What do you guys think? It's false because it's 0 equals 20. That's not a true statement. So 2 comma negative 5 is not a solution. What about this one? Well, let's do the same thing. Replace your x and your y. Go ahead and simplify your calculations. And I get 20 equals 20, which is true, which means that yes, this is a solution of 5x plus 2y equals 20. What does it mean to be a solution? It means if I graph this line, that point is actually on the line. So if I'm substituting one variable in a linear equation, I can solve for the value of another variable. So if I wanted to complete this ordered pair, this is an x value of 2 and a y value that I don't know. So I'm going to replace x with 2, and I'm going to calculate what is y. And I get y equals -5. So I know my ordered pair is 2, -5. Now in B, I don't know my x value, but I know my y value. So I'm going to replace y with 7, and I'm going to solve for x. Using what we know about solving equations, we would need to add 9 to both sides, and then we would need to divide both sides by 2. Now I know that my x value is 8, so the ordered pair is 8, 7. Now, a table of values is very useful when we're trying to graph equations that we may not be very familiar with. We're not really going to use this a lot for lines because lines only require 2 points. But when we start building upon this and we start thinking about, well, how do I graph x squared or how do I graph a square root? These are very valuable. So a table of values is where you have selected values for the x and the y coordinates, and you're plugging into the equation to solve, just like we did before. So if x is 0, and I want to know what is y, I replace x with 0, and I get y equals -4. So I fill in my table of values. This is called an intercept, and it's very useful to know. Then I'm going to replace y with 0, solve it, and I'm going to get 6. So that's the point 6, 0. Again, that is an intercept. That is going to be very important later on. Then I'm going to replace x with 3 and get my point. And last, I'm going to replace y with -3, and I'm going to solve that for x. Now remember, -3 times -3 is +9, so I'm subtracting 9 from both sides there, and that's where the 3 comes in. Divide both sides by 2. And I have a fraction. That's okay. It's okay to have a fraction in the table of values. You don't have to do anything with that fraction. It's just a final answer. So don't get nervous or anxious about having fractions. This is okay. We're not doing math with fractions. We're just saying, hey, 3/2 is my answer. So now we're going to talk about plotting ordered pairs. So now we're going to transition into that graphing section. In the coordinate plane, it's divided into 4 quadrants. So they work quadrant 1, 2, 3, and 4. When I'm plotting, I'm looking at the x value on the horizontal axis and the y value on the vertical axis. So I also call this point 0, 0 the origin, and together this entire graph is called the rectangular coordinate system. So that's a little bit of background on how we're going to be plotting these things. Now, the x and the y-axis divides us into 4 unique areas, and we call it a plane. The ordered pairs are the coordinates. So think about the word coordinate as like the word address. So when I give someone my address, it tells them where to find my house. When I give you a coordinate, it tells you where to find the dot on the graph. So that when we're given the coordinate, the first thing we're going to do is our right or our left movement for the x-axis. Then we're going to do our vertical movement for the y-axis. So if I want to plot the point 3, 5, I'm going to go to 3 on the x-axis, and then I'm going to go up to 5 on the y-axis. Have these cool arrows, right? And there's my point. So you don't actually put the dot until you've done both movements. If I want to go to -2, 6, I'm going to go back to the origin, not from the point I drew, and I'm going to go over 2 to -2 and up to 6 and put my dot. If I want to go to 0, 1, I go back to the origin. I don't go right or left any, and I just go up 1, or down 1, sorry, it's a negative. -5, -2, I go back to the origin, left 5, and I go down 2 to create my new point. So the key here is that you have to go back to the origin every single time. Back to the origin, over to 5, down to -2. Back to the origin, I don't move right or left, and I go down 6. So this is really about getting the x coordinate clear in your mind and making sure you're doing that right or left movement, and about the vertical movement and making sure that's your y movement. So in this one, we're going to look at using a linear equation to model something. So this is my equation. If I want to model something, that just means I'm just trying to find the answer. So if x is going to be for 2007, I'm going to replace the x, it's telling you it's 2007, with that, and I get 137. So this is all it is. It's a table of values and we're given data. So we're just giving the data to you in a slightly different format. Now I'm going to plug in 2008, get my answer, put it in my table. So when we're doing a linear equation and we're modeling, it's really not any different than a table of values.